So imagine you're building a massive industrial restaurant kitchen.
Right.
You buy the commercial ovens, you hire this whole cooking staff, and you basically have to keep the lights and the gas and the ventilation running 24/7.
Yeah, and that is just a fundamentally expensive way to operate because you own all that physical infrastructure.
Exactly. And even if absolutely no one walks through the door at like 3 in the morning, you are still paying to keep that entire kitchen running at full capacity.
Hmm.
And well, that is exactly how we used to build the internet. Welcome to the deep dive, by the way.
It really is how everything was built. You basically bore the entire financial burden completely, regardless of actual user demand.
But then, you look at the modern cloud computing landscape, specifically the world of AWS serverless architecture, which is our topic today, and that whole traditional model just gets flipped completely on its head.
Oh, totally. Moving from owning the kitchen to basically simply ordering off the menu, it changes everything about how we build and pay for technology today.
Right. It's like you no longer own the kitchen at all. Instead, you're just ordering from this hyper-efficient, massive restaurant. And you only pay for the exact meal you eat at the exact fraction of a second you take a bite.
It alters the underlying economics of software development entirely.
Which really brings us to our mission for this deep dive. Today, we are tackling one of the most critical foundational topics for the AWS CLFCO2 exam.
Yeah, the cloud practitioner exam, it's a big one.
Huge. And we've compiled some really targeted study materials and notes designed to demystify these specific cloud computing concepts. So whether you are, actively prepping to pass that exact AWS exam, or you're just trying to understand the cloud buzzwords flying around your next tech meeting, we've got you covered.
We are definitely going to cut through the jargon today.
Exactly. We're going to figure out what serverless actually means, how the pieces fit together, and really just arm you with the exact knowledge you need to master this space.
And understanding the underlying logic of serverless is just crucial. Because once you grasp the mechanics of it, you start to see why it has completely taken over the tech industry.
Yeah.
But to get there, we really have to clear up a very common misconception right out of the gate.
Oh, let's start with the name itself, because I was looking over the concepts in the study materials, and I have to admit, serverless feels a little, I don't know, disingenuous.
It's a terrible name, honestly.
Right. I mean, software can't just run on thin air. There has to be a physical machine somewhere in a data center, right?
Oh, the physical machines are absolutely still sitting there. There are rows and rows of blinking physical servers in an AWS data center right now.
Okay, so the servers haven't magically vanished from reality?
Not at all. The fundamental shift here is that AWS manages them completely on your behalf.
So it's really about abstracting away the heavy lifting.
Precisely that. I mean, if we connect this to the broader philosophy of cloud computing, the goal is always to remove friction for the developer.
Make their lives easier.
Exactly. In a serverless architecture, you don't install operating systems. You don't apply security patches at 2 in the morning.
Nobody wants to do that.
Right. And you don't provision capacity, meaning, you don't have to guess how many servers you might need for the Black Friday holiday rush. That is really the first core pillar, zero server management.
Okay, so as a developer, I just write my code and hand it over.
You hand it over, and then it operates on an event-driven basis. And that's the second pillar.
Event-driven, so it just waits.
Yeah, your code sits there doing absolutely nothing until a specific event triggers it to wake up.
Mm-hmm.
And that leads directly into the third pillar, which is you strictly pay per execution.
Oh, going back to the restaurant metaphor.
Exactly. You are only handing over cash when the chef actually cooks your specific order. If no one places an order for a week, your server bill is quite literally $0.
Which is such a massive departure from the old way of like renting a server by the month and just hoping someone visits your website.
It's night and day.
But if AWS is handling all the hardware in the background, what is actually executing the code? Like, what is the engine making this happen?
Well, that brings us to the star player of this whole ecosystem, AWS Lambda.
The logo.
Okay. If serverless is the overarching concept, Lambda is the primary compute service that actually makes it real.
I was actually trying to wrap my head around how Lambda functions, and the notes keep referring to it as a single unit of work. What does that actually look like in practice?
Think of a Lambda function as a highly specialized worker who only knows how to do one specific discrete task.
Okay. Like what?
Let's say you have an application where users upload profile pictures. The specific task might be taking that large image and resizing it into a smaller thumbnail.
Right.
So the Lambda function sits completely dormant until the trigger, which is the user hitting upload, activates it. It wakes up, resizes the image, and immediately goes right back to sleep.
Wow. But there is a catch here, right? While reading through the exam prep, I noticed a very strict limitation on how long that worker can stay awake.
Yes, the 15-minute limit. A single Lambda function cannot run for more than 15 minutes. Period.
That's a hard limit.
It is a hard constraint built directly into the architecture.
Okay, so 15 minutes max. And along with that time limit, I kept seeing this term cold start.
Ah, yes. Cold starts.
I was trying to picture what that actually means for the code waking up, and it reminds me of living in the Midwest and having to start your car engine on a freezing winter morning.
You know, that physical phenomenon actually mirrors the digital infrastructure really well.
Right. Because if your car has been sitting in a freezing driveway all night, when you turn the key, the engine groans, the oil is super thick, it takes a second to turn over and actually get going.
Exactly.
And that is a cold start. The car works, but there's a tiny delay. But if you just drove the car to the grocery store and back, the engine is already idling and warm. So if you hop back in, it responds instantly. A warm start.
That's a perfect analogy.
Yeah.
Taking that a step further, the reason cold starts exist in AWS is tied directly to the economics of serverless we talked about earlier.
How so?
Well, when a Lambda function hasn't been triggered in a while, AWS essentially spins down the underlying resources to save money. That is exactly how they can afford to charge you $0 when your app is idle.
Oh, I see.
Yeah, they take that compute power and give it to someone else who needs it right then.
So they're constantly recycling the resources in the background.
Exactly.
Mhm.
So when the next trigger happens after a long period of inactivity, AWS has to quickly allocate a runtime environment, load your code from scratch, and run it.
And that takes a second?
Right. That fraction of a second delay while it sets everything up, that is the cold start.
But if another trigger happens right after...
Say a second user uploads a photo right behind the first one, the environment is already warm, the code is loaded,
Yeah.
and the execution is nearly instant.
That makes perfect sense. But I mean, it also raises a pretty glaring question for me.
What's that?
If Lambda forcefully kills my code at exactly 15 minutes, and it occasionally suffers from a delay when waking up, why would anyone use this for a serious business application? Like, why isn't everyone just renting traditional servers where they have total control?
Because in software architecture, there is absolutely no silver bullet. Everything is a trade-off.
Right.
You have to match the tool to the specific workload.
Okay, let's explore those trade-offs then. Let's start with where serverless wins. Unpredictable traffic seems to be the biggest use case in the notes.
Unpredictable traffic is where serverless truly shines. I mean, imagine you run a ticketing website. Most days you get, what, a few hundred visitors?
Sure.
But the moment a massive pop star announces a tour, you get hit with 2 million visitors in 10 seconds.
If you're on a traditional server, that spike takes your website down entirely.
Exactly. Or, to prevent it from going down, you'd have to pay for enough servers to handle 2 million people every single day, which would bankrupt most companies.
Yeah, that's definitely not sustainable.
With Lambda, AWS automatically scales the functions to meet the exact demand. It spins up thousands of concurrent Lambda functions instantly, and then scales them back down to 0 the moment the rush is over.
Wow. So it's perfect for cost-sensitive workloads and those quick, discrete units of work, like processing an order or sending an email.
Exactly.
But where does it fall apart? I mean, if I write a script that takes exactly 16 minutes to process a massive spreadsheet, what happens at minute 15 and 1 second?
AWS forcefully terminates the process.
It just cuts it off.
It hits a hard wall. So for long-running processes, Lambda is fundamentally the wrong tool for the job. You also want to avoid serverless for highly latency-sensitive applications.
Oh, because of the cold starts.
Yes. If you are building, say, a high-frequency trading platform for Wall Street, where a delay of a single millisecond costs millions of dollars,
Yeah.
you cannot afford the possibility of a cold start.
Right. You need an engine that is revving at redline 24/7.
Exactly. And finally, you want to avoid it for complex state management.
State management. Just to clarify, you mean applications that need to constantly remember what a user has been doing over a long session?
That's right. Lambda functions are inherently stateless.
Yeah.
Once they finish their discrete unit of work and go to sleep, they suffer from complete amnesia.
They just forget everything.
They forget everything about the transaction.
Yeah.
If you have an application that requires maintaining a constant unbroken connection and memory of the user's entire journey, traditional servers often make much more sense.
Okay, wait. If Lambda forgets everything the moment it finishes its job, I clearly can't build a whole application with just Lambda.
Mhm.
Where does the memory live? Where do the files go?
This is where we have to look beyond just compute power. Lambda doesn't work in a vacuum.
Okay.
To build a true serverless application, you need an entire ecosystem of serverless tools to handle storage, databases, and messaging.
And I think this is where a lot of people, myself included, honestly, get tripped up. When I hear serverless, I immediately think of processing power, the brain of the computer. But the AWS serverless family at the CLF CO2 exam level includes so much more. You've got S3, which is the simple storage service. You have DynamoDB, their NoSQL database, API gateway, and messaging services like SNS, the simple notification service, and SQS, the simple queue service.
It's a huge family.
Right. And all of these fall under the serverless umbrella.
I do. And it goes right back to our core definition. Zero server management, event-driven, and paying for exactly what you use.
Right.
Take S3, the simple storage service. You don't buy a hard drive. You don't worry about the server holding the data. You just drop a file into S3, and AWS handles all the replication and security, charging you only for the specific gigabytes you use.
Wow.
That is a serverless storage model.
And DynamoDB works the exact same way for databases. I mean, I don't have to install database management software or provision a database server. I just define a table and start throwing data at it.
Exactly.
Let's try to map this whole ecosystem back to our restaurant metaphor from earlier. If Lambda is the line cook doing the actual processing, how do these other services fit in?
Oh, I love this. Let's walk through in order. Your API gateway, that is the front door and the waiter.
Okay.
When a user clicks a button on your app, that request goes to the API gateway. The waiter takes the order and hands the ticket back to the kitchen, which triggers our line cook, Lambda.
Okay, so Lambda wakes up to process the order, but it needs ingredients.
Exactly. And because Lambda is stateless and suffers from that amnesia, it has to pull those ingredients from somewhere else. So Lambda queries DynamoDB, which acts as your pantry, holding all your structured data, like user profiles or inventory counts.
Right, and what if they upload something big?
Well, if the order involves a large file, say a video upload, Lambda stores that in S3, which acts like your massive unlimited deep freeze.
That is such a good way to picture it. What about the messaging services, though? SNS and SQS.
Those are your communication systems within the restaurant. Once Lambda finishes processing the order, it might drop a message into an SQS queue, like putting a finished plate on the pass for delivery.
Oh, I see.
Or it might trigger SNS to send a push notification to the user's phone, letting them know their order is ready. All of these separate services work together seamlessly, and you haven't managed a single underlying server for any of them.
That is a phenomenal way to visualize it, like Lego bricks snapping together. But if we are talking about the exam itself, I know AWS loves to test if you actually understand the boundaries of these categories.
Oh, absolutely. They love throwing in trick questions.
Right. They want to ensure, the difference between traditional infrastructure and this new serverless paradigm.
For sure.
So a classic straightforward exam question might be something like, which of the following is a serverless compute service, EC2 or Lambda?
And based on our discussion, the answer is clearly Lambda.
Yeah.
EC2 stands for Elastic Compute Cloud. It is the absolute definition of a traditional virtual server.
Right.
You choose the operating system, you log into it, you manage it, you patch it. It is not serverless.
But then there is the trickier version, the trap that seems to catch everyone. The exam might ask, is Fargate a serverless service?
Yes. This is perhaps the most common psychological trap on the cloud practitioner exam.
Really?
Oh yeah, Fargate absolutely is a serverless compute engine. But the reason it tricks people is because of what Fargate manages, which is containers.
Okay, let's pause there for a second, because container is a pretty heavy piece of jargon. How would you define a container for someone totally new to this?
Think of a container as a lightweight, standalone package of software. It holds everything your application needs to run the code, the runtime environment, the system tools, the exact library.
It's just all bundled up.
Yeah, it's like a perfectly packed suitcase. You can drop that suitcase onto a developer's laptop or into an AWS data center, and the application works exactly the same way.
That sounds incredibly useful, but why does that trick people into thinking it's not serverless?
Because historically, to run those suitcases, you needed to rent virtual servers.
Ooh.
You would spin up EC2 instances and install container management software on them, like Amazon ECS, the Elastic Container Service, or EKS, the Elastic Kubernetes Service. You had these great portable containers, but you still had the huge headache of managing the underlying servers hosting them.
I see. You see the word container on the test, and your brain immediately associates it with server management.
Right. But then Fargate comes along and removes that underlying layer. With Fargate, you just hand AWS the container, the suitcase, and say, run this.
And they handle the rest.
Exactly. AWS finds the compute capacity, runs the container, and you never see or manage the servers beneath it.
So Fargate is simply the serverless compute engine specifically designed for a container.
Exactly. I cannot emphasize this enough for you. When you see Fargate on the exam, remember it is firmly part of the serverless compute family alongside Lambda.
Okay, I think it's time we put all this theory to the test. Let's really lock this knowledge in. We've got 3 exam-style scenarios built directly from the constraints in our source material. Let's see if we can reason through them.
Let's do it. Scenario 1. A company has an application with highly unpredictable traffic. Some days they have 10 users, other days they have 10,000. They're also extremely cost-sensitive and want to minimize infrastructure spending.
Okay.
Do you choose a traditional server architecture or a serverless architecture?
Well, thinking this through, if I use traditional servers, I basically have to guess my capacity.
Right.
And if I only provision for 10 users, the site crashes on the busy days. But if I provision for 10,000 users, I am paying for an empty kitchen most of the month, which totally ruins the budget.
Exactly.
So serverless, specifically using Lambda, scales automatically, and I only pay per execution. So my answer is definitely serverless.
Spot on. The keywords to watch for are unpredictable traffic and cost-sensitive. Serverless is the clear winner there. Ready for the second one?
Hit me.
Scenario 2. You have a data processing job that needs to run every single night. It consistently takes about 3 hours to run to completion. Should you use AWS Lambda for this job?
Okay, my initial instinct when I hear runs every night is that I don't want to pay for a server 24/7 just for a nightly job. So I'd want serverless. Wait, no, the time constraint.
That it is.
3 hours. Lambda has a hard architectural wall of 15 minutes. It would forcefully terminate the job way before it finished. So the answer is no, I cannot use Lambda. I'd need a traditional server like an EC2 instance for a long-running process.
Perfect analysis. You avoided the instinct to just pick serverless for everything.
Nice.
Yeah, whenever you see a continuous process longer than 15 minutes, Lambda is immediately disqualified.
All right,
Final scenario.
let's hear it.
Scenario 3. Your development team needs to run containerized applications, but they specifically do not want to manage, patch, or provision the underlying servers that hosts those containers. Is there a serverless option for this?
Huh? This is the psychological trap we just covered.
Yep.
They want the portability of containers, but they want zero server management. I know EC2 requires management, so the answer is AWS Fargate. It is the serverless engine for containers.
You navigated the traps beautifully.
Awesome. So let's distill the core takeaways from our deep dive today for you. Serverless architecture does not mean servers don't exist. It just means AWS manages them for you. It's really built on 3 pillars: zero server management, event-driven triggers, and paying strictly per execution.
And you have to respect the constraints. Lambda is your specialized worker, but it has that strict 15-minute limit, and you really have to account for the slight latency of cold starts.
Right. Serverless wins with unpredictable traffic, but loses with long-running or highly latency-sensitive apps.
And finally, serverless isn't just compute power. It's an entire restaurant ecosystem. You've got API Gateway taking the orders, Lambda cooking the food, DynamoDB acting at the pantry, and Fargate handling your containerized workloads.
Just don't let the exam trick you.
Exactly. Building an entire application using purely AWS serverless tools is incredibly powerful. But, as you study these concepts, it does raise one final provocative thought to really consider.
Oh, where are we going with this?
Well, if you build your entire system out of Lambda, DynamoDB, API Gateway, and SQS, you have completely intertwined your application's DNA with Amazon's proprietary ecosystem.
Ah, I see what you mean.
Yeah, these services speak a very specific AWS language. So the question for you to mull over is this: does the massive convenience of a serverless architecture come at the hidden cost of ultimate vendor lock-in?
Wow, that is a fascinating point. To bring it all the way back to the beginning, sure, ordering from that hyper-efficient restaurant means you never have to build or clean your own kitchen.
Right.
But if you ever decide you don't like the chef anymore, well, how hard is it going to be to pick up your entire menu and move it to a totally different restaurant in another city? Something to think about. Thanks for joining us on this deep dive.